All right, so 104, and I want you looking at your yellow card plus what's on here, because we're going to need more than just what's on here. But like on the others, the new ones that we're talking about today are on here, but I want you to be able to find them on the card as well. Because remember, I'm not expecting you to memorize these. Even if you took a hardcore, just pure trig class in college, most likely you would not have to memorize most of these. Some of these you would need to know. There's a difference between knowing them and using them and memorizing them, but just like with anything else, you use them enough, you'll just know them whether you tried to actually remember them or not. But we're not going to use them enough to where I expect you to remember this. But I do expect you to know them well enough that when you see a pattern, you can think, I think that matches something that's on my card, and then you know you can go find it. Okay, you have to be able to function with them. So find these, the sum and difference identities. They're right above the center right here. Tomorrow we're going to talk about the double angles, but then everything else on here we're not going to even talk about. I left them all on here because I wanted you to know what all the basic ones were. But remember, if we haven't talked about something, don't try and force it down that road. At this point, that's not the purpose of what we're doing. Okay, so but if you look at these two, we've got sum and difference, and one of the reasons that we need this kind of thing is if you look at number 1, part of this is the tangent of 5 pi over 18. That's not a value that anybody expects you to know, but maybe if we added or subtracted these together, then in the end we can get it to something that we can actually work with. So if you look at the patterns of what's happening here with the sine and cosine ones, both of the ones that have sine, whether it's adding or subtracting, you have a sine times cosine situation, and then a cosine times sine. Both of these that have cosine, it's cosine times cosine and sine times sine. So that's the kind of pattern that you're looking for. And then we decide if we're going to add or subtract those angles. So right now, obviously, these will match something that we're doing here because we're just kind of practicing with these. So if you look at number 1, pretty sure that's going to match a tangent one, right? Would this be the sum or difference of the angles? The difference. Okay, so this is the tangent of A minus B, which means this then translates into the tangent of 5 pi over 18 minus pi over 36. Okay. So then we need to understand basic fractions. What would our common denominator be here? 36, which means that first numerator will become 10 pi. The second one is still just pi. So then this gives me the tangent of 9 pi over 36. And what is 9 pi over 36 reduced to? Pi fourths. Good. And then what is the tangent of pi fourths? 1. So all that nonsense that was given to us, the answer is just 1, but without actually subtracting those angles and doing that, those aren't values that we would know. Okay. Now, as you do these, if you skipped a step in everything that I wrote, that's fine, as long as you can do it correctly and you understand your fractions. But if I don't write all that out, I always lose somebody because y'all are writing and looking down. And some of you may want to write out every single step so you don't make up math. That's fine too. Okay. What questions you got? Alrighty. So then let's look at number 2. I have a sine times cosine, then cosine times sine situation. So is this going to be a sum or difference of, is it going to be sine or cosine? Look at the ones you have up there. It's going to match what? When you mix them, it matches a sine, right? And then is it a sum or difference? Difference, okay? So then this is equal to the sine of A, which is 13 pi over 10, minus B, which is 2 pi over 15. I feel like before spring break, my handwriting on this board was getting better. Apparently, without practicing for a week, it's really bad again, but I'm working on it. What would my common denominator be here? $30. Be 30, so I multiply the first one by 3, which would give me 39 pi. Second one by 2, which gives me 4 pi. This is sine of, bless you, 35 pi over 30. I can reduce those both by 5, right? So 7 pi over 6. What's the sign of pi sixths? Just pi 6, 1/2. All right, 7 pi 6 is in which quadrant? Third. And then the third sign is what? Negative. So this is a negative 1/2. Oh, my goodness. Okay. Any questions at this point? Even if the question is, how the heck did I know which one to use? All right, so I'm thinking 3 matches a tangent one, right? Would it be sum or difference? Sum, okay? And not just because there's a plus in the numerator. There has to be a plus here and a minus here, and then, you know, and then the pattern still has to work. I'm not going to give you one that we're like, this was 18 pi over 30 and throw you off. I'm not trying to trick you, but just make sure you're looking at the whole thing there. Okay, and so it is the sum. So we get the tangent of 4 pi over 15 plus 17 pi over 30. And then I'll let you finish that one up. Okay, what's the tangent of pi sixths? Square root of 3 over 3. What quadrant is 5 pi 6 then? Second, and their tangent is what? Negative. Good. So this is negative square root of 3 over 3. Very good. All right. Any questions at this point? All right. So I would say number 4 is going to either match sine or cosine. Which one will it be? Sine or cosine? Cosine, because the cosine is cosine times cosine, right? And would this be sum or difference? Sum. Good, because on cosine, the signs are the opposite. So this is going to be cosine of 5 pi thirds plus pi 12ths. And I'll let you finish this one up too. Thank you. All right, what's the cosine of pi fourths? Square root of 2 over 2. 7 pi fourths is in which quadrant? Fourth. And in the fourth quadrant, cosine is positive. So it's square root of 2 over 2. What questions you got? Okay, so those asked us to condense them and then find a specific value. So we were able to get a number from that. Now we're going to simplify them. Now, sometimes when you simplify, you can get something like 1 or 2. I mean, it can be a number when you simplify, but more often than not, it's some sort of single trig expression. So either way, we're not solving. There's nothing to solve because it's no equal sign, and I don't have an actual like unit circle value to use here. So let's look at number 5. So same type of thing. I see a pattern. I have a cosine of A times cosine of B plus sine of A times sine of B. So is this going to match sine or cosine? Cosine. Is it going to be sum or difference? Difference, right? Okay. So this is going to give me cosine of 2x minus 4x. So that gives me the cosine of negative 2x. Now, I can actually simplify that some more. I want you to look at your chart. I want you to find the even and odd identities over on the right. So if we thought of this right here as this 2x being theta, this is like the cosine of negative theta, right? So if you look on there, cosine of negative theta, what does cosine of negative theta equal? Cosine theta. Because remember, cosine of pi 6 and cosine of negative pi 6, they're the exact same thing. So if I look at this as just being cosine of negative theta, that means that cosine of negative 2x is just cosine of 2x. Does it work the same way for sine? No, because that would be negative sine of 2x, right? But it's not a factoring out. That's what you have to be careful with. It's not like, because like right here, I can't factor this 2 out in the front and say this is the same as 2 times the cosine of x. It's not the same thing. So even if there's a negative there, I don't get to factor the negative out in front. It doesn't work that way. You have to use this. Okay, we good? Everybody see it over there? All right. And let's look at number 6. Sum or difference of tangent. Sum. So this is going to give me the tangent of 4 theta plus theta, which gives me the tangent of 5 theta. Right. Now, if you look at this chart, below where we are today for the sum and difference, you see the double angle identities? That there actually is a cosine of 2 theta. There's an identity that matches this one right here. But the most condensed version is the cosine of 2x. I wouldn't change it into one of these. Even if I could, we haven't actually talked about them yet, so I wouldn't. But there's no cosine of 5 theta. But we could split things. That's why we looked at the sum and difference. You know, we could split it differently and do some different things with it. But we're not going to get into all that. Just want you to know, don't try and force anything down any other road. All right, so let's look at number 7. Is 7 going to match sine or cosine? Sine. And is it the sum or difference? Difference. Does everybody understand how we're figuring that out by looking at those patterns up there? Okay. So that means that this gives me the sine of pi halves minus alpha. All right. So now that looks like something that is familiar to me on this chart. So look at everything we have looked at so far. Do you see a sine of pi halves minus, I mean, it's theta on here, but do you see a sine of pi halves minus theta anywhere? What does that equal? Look at your cofunction identities right here. Yeah, so that means that this is just going to be cosine of alpha. That's my answer. Okay. What questions you got? Okay. Now look at number 8. It's tangent, right? Is it sum or difference? Difference. Okay, so then that'll give me tangent of y minus pi halves. Now this looks very similar to what we did in number 7, right? The difference is, and I know that this is y, and on there it's theta, and we used alpha, it's all fine, but you don't have a tangent of theta minus pi halves, it's pi halves minus theta, right? And those are not the same thing. You can't subtract in any order. You can add, but not subtract. So I would like to see if I could flip this around. Sometimes you flip things around and it works, sometimes you don't. So we're going to make this into tangent of, now when I flip it around, that negative pi halves, that negative's still attached to pi halves. So I have this, okay? Which now at least they're in the right order, even though the signs are not correct. Could I do something legally to the inside of that to make that into pi halves minus y? What could I do? I could factor out a negative. Now be careful where you factor this negative out to. This is still going to be the tangent of negative, and then this is pi halves minus y. See what I did there? Because remember, you can't just factor it all the way out in the front. It doesn't work that way. Although you may not believe me here in just a second, because if I look at this as tangent of negative theta, so if I think of this as this right here, as this is my angle, so I'm just going to think of it as theta. Now look at your little charts for your even and odd identities where the negative signs are. What is tangent of negative theta? Negative tangent of theta. So this becomes negative tangent of pi halves minus y. But I want to remind you, we knew we could go from here to here by the chart. I did not take this and factor it out right here because that is not what happened here, right? That's not what's happening. You get to do that because of the identity. So now that I look at that, so now I have basically tangent of pi halves minus y. Is there something that matches this part right here? Cotangent, which means this is negative cotangent of y. And you're done. It's all about substituting legally from this chart and doing like this, factoring out of the negative. That's an algebraic skill, right? That's being able to factor that out. That's algebraic. But then the substituting and everything, that's coming from your reference card, okay? Are we good? What questions you got? All right, so I'm going to give you a worksheet, and then we're going to fix number 2. We're going to fix number 2. I am bound to determine not to forget that any class period today. You should be able to finish this, I think, before you leave. And the key is up there on the podium. Put one here for Amy. If somebody could fix hers, that'd be nice. All right. Everybody got their worksheet in front of them? It's a very simple fix, but you look at number 2 in the denominator, that should be 1 plus, not 1 minus. So make that into a plus sign. I didn't catch it till after I copied it. Okay, so fix number 2.